Welcome to Summarize Science. Today, we're looking at a fascinating problem in the world of AI, the need for massive amounts of training data. Often, the best way to get this data is to have other AIs create it in a process called synthetic data generation. But what if the system managing these data-creating AIs is inefficient and slow? Researchers from Meta AI have introduced a new framework called Matrix to solve this exact issue. Most current systems use a centralized orchestrator, which is like a single manager telling every worker agent exactly what to do. This manager quickly gets overwhelmed and becomes a bottleneck, slowing down the entire data factory. Matrix's brilliant solution is to get rid of the central manager entirely. It uses a peer-to-peer design where control and data are passed between agents like a note in a classroom. Once an agent finishes its part of the task, it simply sends the work directly to the next agent in the workflow. This decentralized approach allows tens of thousands of tasks to run at the same time without waiting for a central boss. A key reason for its speed is something called row-level scheduling. Imagine a long assembly line where the next batch of work can't start until every single item in the current batch is finished. If one item is slow, the whole line stops. Matrix avoids this by letting a new task start the moment any single agent becomes free, ensuring the expensive computer hardware is always being used. The performance results are pretty staggering. In one experiment, they compared Matrix to an existing system for generating reasoning dialogues. The old system's performance flattened out quickly, while Matrix's scaled almost perfectly as more computing power was added. Ultimately, it achieved 6.8 times higher data throughput. In another, even more demanding test involving tool use and simulated customer service environments, the difference was even greater. The baseline system hit its limit very early on. Matrix, on the other hand, just kept scaling, generating an incredible 15.4 times more data per second than the baseline. And importantly, it did this without any drop in the quality of the data being produced. They even added clever optimizations like message offloading, which reduces network traffic by about 20%. This is like sending a link to a large file instead of attaching the file itself, making communication between agents faster. So let's recap the key points. The Matrix framework gets rid of the central bottleneck in multi-agent systems by using a peer-to-peer design. This allows for fine-grained scheduling that keeps hardware busy, resulting in a massive 2 to 15 times increase in data generation speed. What does this mean for the future? This technology could make it significantly faster and cheaper to create the specialized, high-quality data needed to train the next generation of AI. This could accelerate breakthroughs in everything from science and medicine to creative tools, and the researchers plan to open source the framework for everyone to use.